I am here for the last lesson of this chapter. We have chapter 6 almost in the books. We're looking at page 208. This is Compare Functions in lesson 6.4. And in my very humble opinion, this is one of the most useful chapters or lessons in this book. Everything we've learned so far has been leading to this particular lesson, at least with respect to graphs, I think. Okay, so I'm on page 208. And let me just take a look. I have not previewed this, which is not very smart of me. Okay, this is talking about proportional relationships. So I want to how much do we want to review? Let's review just a little bit. And they use a particular type of graph to tell you about this concept. So let me draw that. If you don't have the textbook, you can follow along with me here. So draw yourself a coordinate plane, and let's put a line, a linear function through there, right through origin. Okay. We're off to a good start. Maybe this chapter will go very smoothly. Okay, so you have learned that a linear function takes the form y equals, or can take the form y equals mx plus b, where b is the y-intercept, where it touches the y-axis. That's right there at origin. And y stays in the problem. M, we've learned, is slope. So let's calculate the slope here for this one. It's going to be rise 1, run 1, rise 1, run 1, rise 1, run 1. So this is a slope of positive 1. So y equals 1x plus 0. And the 0, of course, drops off. The 1 is a ghost, so we're saying that y equals x. Everywhere you have an x value, you will have the y value being equal. This is about as basic a linear function as we can write. So this should not be new at this point. Now, you've also learned that we can take this notation and substitute f of x for y. So this means exactly the same thing, saying the same thing. Do you remember the letter K? It's been a while since we've talked about that. That was in the last chapter. K was called the constant of proportionality. And remember, for us to use the letter K, we had to meet the 0, 0 test, and this function clearly does. It passes right through 0, 0. So given that is true, we can also write our equations this way. Y equals k x plus b. But in this case, the y-intercept is 0, so b is not a factor. So the k and the m are used interchangeably as long as you have a proportional relationship. So most of that, if not all of that, is review, but it's been a while since we thought about it. And that's what they're talking to you about on page 208. That you have a proportional relationship if the ratio of y to x is always equal to a non-zero. K cannot be 0, because if it were, you wouldn't have any proportionality. Now, don't get excited about what I'm saying here. I know that's a lot of mumbo-jumbo to a certain extent. But when we put some actual stories with it, I think that it will be a little bit better. So page 208 is just reviewing some of the concepts we've learned so far and talking about the concept of a proportional relationship.